So these are the notes for lesson 10-4, the perimeter and area of similar figures. So what you'll see in this section is not just one figure like a hexagon or a trapezoid or anything like that. You're going to see two figures that are similar. And you should be able to figure out the area or the perimeter of one figure based on the area and perimeter of the other. So there's going to be a relationship between the two figures because they are similar. Okay, they have a ratio set up here. If the similarity ratio, which also means the side ratio, if I just compare one side to another side, that is also the similarity ratio. If it is in a ratio of A to B, then the ratio of the perimeter is also in that same A to B. The ratio of the area is not A to B, it is A to B, but you've got to square these numbers, square. Okay, I drew two pictures here to the right. These are two basically squares here. The similarity ratio would simply be comparing the side length. So like this side length is 1, this one here is 3. So we would say the similarity ratio of this guy is 1 to 3. The perimeter ratio would also be 1 to 3. But if you actually did the perimeter here, the small one, it would be 1 plus 1 plus 1 plus 1, which is 4. This one would be 3 plus 3 plus 3 plus 3, which is 12. Well, if I compare those ratios, it is 4 to 12, which reduces down to 1 to 3. So it's the same exact ratio as the sides. Now the area is not 1 to 3. The area, of course, is space inside. If I look at the small picture here, it has an area of 1. This one here has 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're not going to say the ratio is 1 to 3 for the area. It's going to be 1 to 3 squared. So 1 times 1 is 1, 3 times 3 is 9. The area is actually going to be 1 to 9. This square in red is 9 times bigger area-wise than the original one, which is a 1 by 1 square. All right, number 1 here. Find the two similar polygons have corresponding sides of 5 to 7. So I just drew two figures here. It looks like parallelograms, 5 inches, 7 inches here, and they are both similar. All right, so part 1A, find the ratio of the perimeter. It will be basically the similarity ratio is 5 to 7, and the ratio of the perimeter is also 5 to 7. Now, I don't know if the actual perimeter is 50 inches to 70 inches, but I do know it reduces down to 5 to 7. Part B, the ratio of the area. It is not going to be 5 to 7. We are going to have to square it. So we're going to square the 5 and square the 7. So the actual ratio of the area is 25 dot dot 49. 25 to 49. Okay, number 2, the corresponding sides of two similar parallelograms. So I drew two parallelograms here at the bottom, is a ratio of 3 to 4. You can obviously see one is bigger than the other. The area of the small one, or the larger one, excuse me, is 96 inches squared. Figure out the area of the smaller guy. So we're not going to do any type of base times height formula. What we're going to do is set up a proportion. We're basically going to say 3 on the small one, 4 on the large one is equal to, I don't know, X area on the small one over 96. That's your proportion. However, before you cross multiply it, you are actually, this is a side ratio, the 3 to 4. This is an area ratio. In order for the area ratio and the side ratios to be equal, you've got to square these numbers. So we are going to square these here before we cross multiply this. So this will be 9 over 16 is equal to X over 96. Now once you're there, now you just cross multiply this and get your answer. And I'll just do this real quickly. Divide by, the answer should be for the smaller area, 54 inches square. But you've got to remember, this is the key, to square the side ratios in order for it to equal the area ratio. Okay, number 3 here, the similarity ratio of the dimensions of two similar pieces of glass windows is 3 to 5. So I drew two windows there on the bottom. smaller piece costs $2.50. What should the cost of the larger piece be? So this will be our X here, down here. Again, even though I drew a rectangle, it is not a base times height type problem. It's a comparison problem. And when you do this, you're basically going to say small to large is equal to small price, $2.50, to large price, I don't know, X. Now, before we cross multiply this, you've got to ask yourself, when you buy a window, what are you buying? Are you buying the outside edge perimeter? Or are you buying the inside area? Well, window is basically you're buying the inside area. You are not buying the outside perimeter. So this, even though it says a price number, this really represents area. And so this guy here is area as well, because when you pay for the money, you are buying the area of the window. So this ratio 3.5 equals 250 over X. Before you cross multiply this, this is the side ratio. This is the area ratio, but the side ratio is not going to be equal to the area ratio unless you, and again, this is the key for today's work, you square these numbers here on the side. So this will actually be 9 over 25 is equal to $2.50 over X. Saving time here, this should end up being, the bigger piece of window should be $6.94.